Hello dear students, let us continue the atom chapter. So in this class let us study about Bohr's theory of hydrogen atom. So in this class we will derive the expression for radius of an orbit of hydrogen atom. So before deriving the expression for radius of an orbit of hydrogen atom, so let us have the brief revision of last class, whatever we studied. In my last class we studied about the postulates of Bohr's atom model. So we have three postulates. So the first postulate explains about the stationary orbits in which the electrons are revolving. So the first postulate states that an electron revolves around the nucleus with a definite fixed energy in a fixed path known as stationary state without gaining or losing the energy. So the second postulate is the quantization of angular momentum states that electrons can revolve only in those energy levels in which its angular momentum is an integral multiple of h divided by 2 pi. So that is L is equal to nh divided by 2 pi. So n is the principal quantum number, n equal to 1, 2, 3. H is the Planck's constant, L is the angular momentum for the nth orbit, m, vn, rn, that is equal to nh divided by 2 pi. M is the mass of an electron, v is velocity of an electron, r is radius of the orbit. As usual, h is Planck's constant. So in the second postulate, it explains the Bohr's quantization condition for angular momentum. The electrons can revolve only in those energy levels in which its angular momentum is an integral multiple of h divided by 2 pi. So this is about the second postulate we studied in my last class. So the third postulate, when electron can make a transition from higher energy level to lower energy level, radiating energy in the form of a photon. So the photon energy is the energy difference between the two energy levels, that is equal to h nu. H nu is the energy difference between the two energy levels, that is EI minus EF. So the energy of the photon is given by E equal to h nu. So that can be written EI minus EF with the condition EI is greater than EF. So during its transition, energy is emitted in the form of a photon. So the photon energy is the energy difference between the two energy levels. So we can explain this by Planck and Einstein equation. So this is what we discussed in my last class. So in this class we'll discuss about Bohr's theory of hydrogen atom. So in that, let us derive the expression for radius of an orbit of hydrogen atom. So now what is the expression for radius of an orbit in case of a hydrogen atom? So let us consider the Bohr's theory of hydrogen atom. So using Bohr's postulate, we will have the expression for radius of an orbit. So hydrogen atom, we know that hydrogen atom consists of a nucleus having charge plus E. So this is the nucleus. The charge of this is plus E, since we are considering hydrogen atom, Z equal to 1. And an electron having charge minus E, so that is revolving around the nucleus in a fixed orbit. The radius of the circular orbit is r. So this is the circular orbit and radius of this is, let us consider r, and electron is revolving, so the charge of the electron is minus e with some velocity v. So this is what the initial construction to get the expression for R. So we have the nucleus, the charge of the nucleus is plus e. Around this the electron is revolving in a fixed orbit and whose radius is r. Charge of the electron is minus e and it is moving with some velocity v. So now let us consider the Coulomb's force of attraction between the nucleus and the electron. So that is given by the Coulomb's force. So now take this as F is equal to 1 divided by 4 pi epsilon naught. Charge of the nucleus, also charge of the electron, E. Directly I will take this as a E square, E into E, divided by, for the nth orbit we are considering, so therefore let us take this as Rn. So this is the distance between the nucleus, also the electron. So now let us call this as equation number 1. So this force provides necessary centripetal force for the electron to circulate. So now we can write, so this is the Coulomb's force. So now this is equivalent to the centripetal force. We can write centripetal force Fc, that is equal to the Coulomb's force, that is Fe. Okay, now we know the value for centripetal force. Centripetal force is given by mvn squared, since we are considering for the nth orbit, mv square divided by r. So this is now Rn. So that is equal to the Coulomb's force, 1 divided by 4 pi epsilon naught E square divided by Rn square. Rn square. So now we can cancel Rn, here also 1 Rn. So let us erase this. Yeah. So now after cancelling Rn on both sides, so we'll get the expression as m vn square, that is equal to E square divided by 4 pi epsilon naught into Rn. This is my one more reference equation to get the value of R. So call this as equation number 2. So now according to Bohr's postulate of quantization of angular momentum, we have just now we studied, so in the beginning of the class, so that is m vn Rn. So angular momentum is equal to integral multiple of nh divided by 2 pi. From this get the value of Vn. So Vn expression, so therefore from Bohr's postulate of quantization of angular momentum, we got the Vn value as Vn is equal to nh divided by 2 pi m Rn. So call this as equation number 3. So now substitute the value of Vn, so that is equation number 3, in equation number 2. So now we get, therefore, so let us take equation number 2. So M NH 2 pi M Rn the whole square, that is equal to, so I'll rub all this and I'll write one more time. Okay, so now let us substitute the value of equation number 3 in equation number 2. Let us check the equation. So M NH divided by 2 pi M Rn the whole square, that is equal to E square divided by 4 pi epsilon naught into Rn. Okay, so now you can cancel some of the terms here. So now I can cancel M, here also 1 M, so 1 M remains in the denominator. Also I can cancel 1 Rn, here also 1 Rn. Also this pi, also 1 pi, also this 4 and this 4. So now let us check what we left with. So here it is n square h square divided by, so we left with 1 pi here, pi, also m and Rn, that is equal to E square divided by epsilon naught. So therefore we should get the equation for Rn. So therefore Rn is equal to, it is n square h square epsilon naught divided by pi m e square, pi m e square. So let us call this as now equation number 4. So observe equation number 4, since h epsilon naught pi m e square all are constants, so we can say that Rn is directly proportional to n square. So if we substitute the values of all the constants in this equation number 4, we will get Rn is equal to some constant number into n square. That constant is denoted by now A naught. Okay, so now that constant is h square epsilon naught divided by pi m e square. So this is said to be the constant as we observed in equation number 4. Therefore, we can write Rn is directly proportional to n square. Thus, the radius of an orbit is directly proportional to the square of the principal quantum number n of the orbit. Since n we can take it is 1, 2, 3, 4 and so on. It is an integer. Hence the ratio of the radii of the orbits of hydrogen atom. So if I consider for n equal to 1, 2, 3, 4 and so on, it is like n1 is to n2, n3 and so on. So it is equal to 1 is to 4 is to 9 is to and so on ratio. So if I consider for n equal to 1, so the radius of the innermost orbit, so that is n equal to 1 for an electron in hydrogen atom is called Bohr's radius. So that is denoted by A0. So when I substitute all the values of the constant, I'll get the general expression as Rn is equal to, it is A0 times of n square. It is Rn is equal to A0 times of n square. A0 is said to be the Bohr's radius, the innermost radius, the radius of the innermost orbit for n equal to 1 of an electron in hydrogen atom. So the value of A0 came out to be, by substituting all the constants, so the value of A0 is A0 equal to 0.53 angstroms. 0.53 angstroms. So this is said to be the Bohr's radius for n equal to 1. So this is said to be the radius of the innermost orbit called as Bohr's radius. Equation number 4 is said to be the radius of an orbit of hydrogen atom. So in this we studied Rn is directly proportional to n square. Also the Bohr's radius is given by 0.53 angstrom by considering n equal to 1. So I'll give all the constant values. So as you know well, also you familiar with all the constants to get the value of Bohr's radius. So let us list out them. First, charge of an electron. Charge of an electron E is equal to 1.6 into 10 raised to minus 19 coulomb. Similarly, mass of the electron, that is equal to 9.1 into 10 raised to minus 31 kg. H is Planck's constant. H is equal to 6.6 into 10 raised to minus 34 joules a second. Also epsilon naught, absolute permittivity 8.854 into 10 raised to minus 12 coulomb square per Newton meter raised to minus 2. So by substituting all these constant, we'll get the Bohr's radius value A0 is equal to 0.53 angstroms.